Okay, section 3.2 is the graph of a function. So we said that another way to show a relation, which a function is a relation, we said we could use ordered pairs, we can use an equation, we can use a graph, and we can use mapping. So we've seen some ordered pairs and figured out, is this relation a function? We looked at some mapping the same way. Now, what if we were given a graph of a relation and we're to determine whether or not that relation is that special subset called a function? So what we can use to determine this is something called the vertical line test. And the vertical line test theorem says that a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in, at most, one point. So every vertical line you could draw can cross it 0 times or 1 time, but the most is once. Okay, so we'll practice that here with these examples. We're given a graph, a set of points in the xy plane, and we're to determine whether or not it's a function, and either way, we'll state the domain and range. Okay, so imagine every possible vertical line, and you can actually see some drawn here on the grid, and we notice that all vertical lines we can even imagine will only intersect this parabola once, right? The most is once. So yes, this is a function, and its domain from low to high, the lowest value for x on this graph would be -infinity, and the highest would be +infinity. The range does have a restriction. It doesn't go any lower than the origin. So it goes as low as 0 and as high as infinity. Okay, applying the vertical line test in number 2. Imagine vertical lines crossing this graph. Okay, and what do we see? Do we ever intersect more than once? No, we don't. So this also is a function with a domain of all real numbers and a range of all real numbers. All right, let's look at C. Now we have a parabola, but this one is opening to the right. Out here we see vertical lines that make no contact with the graph whatsoever, 0. But do we ever intersect more than once? The most can be once. Well, yes, this vertical line and many others do intersect more than once. So this is not a function. Its domain, the lowest possible value for x, would be right here at the origin, 0, and then it goes all the way to +infinity. The range, with arrows on either end, say all real numbers. Okay, and finally, what do we have here? Out here, vertical lines don't intersect, but at some point we can see a vertical line crossing this graph in more than one location. So this is not a function. Its domain, left to right, that would be what? -3, all the way to +3 for the domain, and -3 to +3 for the range. So what we're seeing is a parabola that opens up would be a function, but it opens right or left would not, and certainly any circle or ellipse would not be a function. So in conclusion, using the definition of the function from section 3.1, state why the vertical line test works. Well, remember that the definition said that each x is associated with exactly one y. So let's see if we can make this work. We know that on a vertical line, all values of x are the same. All the x coordinates are the same on a vertical line. So if every vertical line intersects the graph in at most one point, which is our criteria, then that means each x will be associated with exactly one y. Each x will be associated with exactly one y. So on a vertical line, all the values of the x are the same. For example, here, this was the point 1, -1. This is the point 1, 1. Okay, but because we intersect at more than one point, we have one that gives you -1 and one that gives you 1. It's not predictable, right? So it's not a function. But if the vertical line intersects at most one point, then you know each x is associated with exactly one y.